guys? Is it working pretty good? If anybody else wants some, I have more Velcro. See how Max has it. It's that way when you're carrying it, it doesn't flop open by mistake. It's a little easier to carry. All right, so we are going to go over residuals, coefficient of determination, and standard deviation of residuals, which means that we are going towards this last step. And today is all about, so we have dots, and we've shot a line through them using least squares regression. So how good is it? Just like we use the normal distribution to find out the percentages, got into the details. This is kind of the details of everything today. And there are a couple sentences. We'll definitely need our generic examples, or I mean our Cliff Notes packet today. There's a couple big sentences, not huge, but there's a couple more sentences that are really important, and it's kind of a catch-22 because trying to explain them before you really understand, trying to learn how to say them before you really understand them is a difficult thing, but we're going to have you practice saying the sentences a lot, even if you don't truly understand what you're saying, kind of like we did when you said use the 5-number summary before we actually taught you the 5-number summary. That's a little bit of what's going on today. All right, so our objectives are to calculate and interpret residuals and their standard deviation, explain the concept of least squares. We're going to do that a little bit. Determine the equation, we already know that. Construct and interpret residual plots. So that's what we're doing today, and we're finally touching this last step, but these 3 last steps we kind of go back and forth on. All right, so the first thing is called the coefficient of determination. That's R squared. And R squared is more important than R because R squared kind of tells us, because we have X's helping us out with the Y's, how much are we, quote unquote, saving? It's like a discount at the store. The original price of a coat might be $100, but if it's 20% off, how much are you going to pay for it? $80, right? So 20% of the price can be explained by the sale, and the other $80, the other 80%, you're going to be doing based on the original. So R squared compares, if you just had the Y's, what would your errors be compared to the mean? So if you just had your Y values and no X's to help you, what would the standard deviation basically be? What would the typical error be of the distance they are from the mean? But now that you have the X's, how much better are you? And that's a percentage that it gives. So we're going to talk about that, and that is in your packet, and you need your highlighter. If you don't have them, they're right behind Sam. We are on page 8 in our little packet. Yep, Trent right there in the middle. And supposedly, does it say front on them? They're supposed to be put how you sit, but I don't think they are because Molly's over here. It should be over there. Here's yours. Oh, you got it? Yeah, so these really should be like this. Molly should be here. There we go. All right. Yes, sir. Yeah, we're gonna use that some, yes. Okay. But probably not today. Okay, so the sentence we have to memorize is down below here. Blank percent of the way the Y's go up and down can be explained by the variation or the ways the X's go back and forth. as calculated by the least squares regression line of y values on x values. So we're going to put context in for the words x values and for the words y values. But everything I underline stays as it is. So these we're going to put in with the context. And tomorrow when we watch a little video by the AP Stat guy, he does a phenomenal job at explaining this sentence and what R squared is really all about. But if we watch it right now, it will be kind of a waste because you don't really know enough about it to appreciate what he's going to do for us tomorrow. Okay, so let's go to the backpack. And we could waste a lot of time going stat, test, ln-reg, t-test to do this. But instead, we're just going to give you the data and we're going to write the sentence. So we get used to doing this. Okay. So before I write the sentence, let's remember that x, and I gotta copy this because I gotta be ready for the next block. All right. So let's remember that in the backpack, x is equal to your body weight, and y is equal to your pack weight, your backpack weight. And I should have the other thing up, but we can tell here that it's it's pretty strong. It's close to 0.8. So it's not very strong, but it's definitely in the strong category. And my R squared is 0.6315. So R squared is 0.63. And we just pick that right off of there. You don't have to calculate it. But if you did need to calculate it, how would you do it? Take R and square it. So you could put this value into your calculator. You could use Norman and go grab that value. I'll show you how to do that real quick, just so you know. You guys don't have to use the calculator to do this right now. Come on, I don't want that. Yeah, that's what I want. So if I was doing body and pack, which I don't have up here, but I will shortly. I know you can't really see what you need to see. I will get that. And hit y equal, get rid of that. Okay, so that's our body and pack. And this is a little bit chopped up because we've been doing all of these in pieces parts. So I get it. We will do a couple packets, well, more than a couple the whole way through. So you'll get the entire flow. Okay, I have to put body in here. And pack in here. So those things on the screen we got with this. And I can hit graph. And that's what we have if you look at page 12. That's page 12, and we have the R squared in. And then on the top of page 13, we did this, I think, 2 days ago, didn't we? Or was it yesterday? We did yesterday. We calculated LSRL by hand. So this was on Monday. And if I wanted to find out where Norman stores this, I would go to vars. It's a statistics variable. Do we have R down here? No. So let's try, is it part of the equation? Yeah, there's R, number 7. So if I hit number 7 squared, it should give me 0.79. Oh, no, it should give me the 0.63. Because 0.7, yeah, 0.79 is the R squared is 0.63. So you can find all those pieces, parts in your calculator. Norman stores everything. All right, so we're going to form the sentence. So if you're looking at your generic packet, I'm going to say the following. I'm going to say 63% of the variation. So 63% of the way people's pack weights, because that's Y. Y comes first in this sentence. So 63% of the variation in how much your backpack weighs can be explained by the variation in how much the people's bodies weigh. That's what we're saying. 63% of the variation in backpack weights can be explained by the variation in body weights. And the next part of the sentence, or the next, how did we get that 63? How was that calculated? Well, we say as calculated by the least squares regression line of, and the regression line regresses the y's on the x's, so that's why it's y on x again. So I'm going to say regression line of pack weight on body weight. And the next time we go to write least squares regression line, you can put LSRL, and you can do that in your homework, but on your team test and on your own test, I want you to write it out. Okay? But for me, we can do LSRL when we get to this part. So right now, I'm not asking you to fully understand what that means. Tomorrow, after you watch the AP Stat Guy, he does a phenomenal job. Such a good job, I don't even want to try to copy it. All right? But basically, because we have X's, we are saving ourselves a 63% discount on the errors and mistakes we would make if we didn't have the X's. That's what that 63 means. So that's pretty good. And we knew it was going to be pretty good because this is a pretty strong R and R squared. We said the model looks strong. So it should be a high discount. And I would definitely go to Kohl's if they were having a 63% off sale. I'm more likely to go to Kohl's when I get a 30% off. They always send you with like 30, 25, and 15. 25 and 15 don't do much for me. I always love when they hand you the receipt at Kohl's and say, look, last time I went, I saved $350. I'm like, just think what would have happened if I wouldn't have come here today. I wouldn't have saved any money at all. Also wouldn't have spent like close to a couple hundred. But, okay, let's do this again for our sprint. Now the sprint's going downhill, right? Was the sprint stronger? What was the R of the sprint? Anybody remember? You guys have it right there. Negative 0.83. So this is a stronger correlation. It's going the other direction, but just because it's negative doesn't mean it's weaker, right? So these dots are tighter together. That's what the R tells us, how tight the dots are, how nice the little baby ducklings are marching behind the mama duckling. You think of that? That's what R does for us. How tight is the ellipse, and R squared tells us how helpful it is. So we have to remember that what is X in this data set of speed and long jump of field day? I guess I just told you. Yeah, X is the sprint time, and y is the jump distance. And we wouldn't need to write that down except for we are doing these in these chunks. So our r squared is going to be 70, which is higher than last time. So 0.70, we rounded 2 places. And we're going to have somebody help me with the very beginning of this sentence. So it starts off with 70. All right, Jenna, you can give me the first phrase. 70% of what?
Of the variation in long jump distance can be explained by the variation in sprint time.
Excellent. So 70% of the long jump distance can be explained by, and be careful because yes, I do want you to memorize this sentence. This word is variation, not variability, not variance. It's variation. And this is explained by, it's not the y's being calculated by the x's. That doesn't happen either. So 70% of the variation in long jump distance can be explained by the variation in sprint times as calculated by the LSRL, least squares regression line, of inches on seconds. Or you can put of jump distance, whatever you want to do. Jump distance on time, or sprint time, or something like that. So let's think about this. This is telling me that to be a good long jumper, 70% of the good long jumping is your speed. So there's 30% that's not explained by your speed, right? What other things do you need to be a good long jumper? Powerful legs, so your muscle structure in your legs. Maybe your height explains it. What other kind of things? What makes somebody be a good jumper? Because for high jump, you don't need to be speedy.
Technique.
Yep, technique. So there's 30% that isn't explained by speed. It's explained by other things. But this is telling us that most of it is explained by how fast you are. Usually people who can run the 100-meter dash pretty quickly are also very good long jumpers. But it is a conflict of interest. Anybody run track and field? Because what's the conflict of interest between being a jumper and being a sprinter? You have to be at the long jump pit, but your 100-meter dash is going off, so you have to leave and go over there. And for the person running the long jump pit, it's kind of a pain in the butt because they're waiting on you. It's really a pain if you're a high jumper because they can't move the bar up until you jumped. And you get so many minutes after your running event to take a break. And fun fact, we saw Denzel Ward. He got beat by who? Does anybody know? In the Ohio State track and field race. I believe this is the case. Andy Isabella. Does anybody ever remember his name? He's from Mayfield. He went to, where'd he go play college? Anyway, Andy Isabella is kind of like a shorter white dude, and it was amazing to be at the Austintown Pitch race. And my husband and I saw the two of them race 100-meter dash. And in the 100, I think Andy Isabella beat him in both of those. And now Andy Isabella plays for the Arizona Who's the NFL team in Arizona?
Cardinals.
Cardinals. He plays for the Cardinals. And Denzel plays for us. And is Kareem Hunt from around here too?
Yeah.
Because we saw him race. I don't think they're quite the same age, but we saw him doing the high jump. And he had just pulled a muscle in the 100-meter dash. And so he still could jump like 6 feet with a pulled hamstring or something. I don't know, he's pretty good. Okay, that's why my husband and I like to go to the Austin Town Fish regional meet, because you can, we also saw the guy that's I think he is, his last name Price, he threw shot put. He's from Ohio, and he was, I think he's the center for the Bengals. Is anybody? Anyway, it was more impressive, obviously, to my husband because he remembers all this crap. Because every time, I don't know if you guys have a relative like this, we're watching a game or something, and my husband will spout out something, and 2-3 seconds later, that's what the announcers or the sportscasters on TV say. I'm like, you missed your calling. You should do that. Okay. All right, and now we're going to do the animal data with R squared. So we're turning to page 24. And I have to remember to make a copy of this. I didn't want to do that. I want to clone the page. Okay, so our animal data, what was our X values? Gestation period in days. And our Y was our lifespan in years. And this is not as strong of a correlation or association because R is down at 0.4, or R is, 0.66. So that just makes it moderately strong. And R squared, therefore, is less. What are we going to use for R squared in this case? 0.44, because 4399. So I'm going to say 44% of, and we are going to call on Trent. 44% of what?
The variation and animal lifespans, and the explained by variation and gestation.
44% of the variation in the animal lifespans in years, I'll put, can be explained by the variation in gestation. Yep, I know, I spelled it wrong. Gestation period days. And how did we get there? As calculated by years on days. Or you could say, as calculated by lifespan on gestation. Yes.
Is your alarm?
No, that's next door, because Debbie sets her alarm all the time to remind her of important things. And Debbie is, I think, using the ladies' room. And when she gets back to her room, she probably has to make a phone call or something. She does that all the time, and I should do it more, so I remember to do my cohort duty. All right, so this is saying that how long animals live is only explained 44% by how long their mommies carried them. So there's a lot of explaining to do. 56% of how long animals live cannot be explained by how their moms carry them, or how long their moms carry them. So what's up with that? Like, why is long jumping 70% explained by speed, but lifespan of animals is only 44% explained by their mom's gestation periods? What else could be going on? What's the 56%, do you think? What else goes on with animals that makes them less correlated in gestation and lifespan? I can think of a zillion things. Hunters, like maybe where they live and how close they are to civilization and us nasty people hunting them down. My favorite political sign says, did I already mention this? Dogs for president because humans suck. I'm like, yes, I would love to have a dog as a president. Oh, okay, I'll just keep the rest of the comments to myself. Yes.
Their size.
Their size.
What they eat.
What they eat. How about who they eat, or more importantly, who eats them, where they are in the food chain. So maybe where they're living, what kind of environment they're living in. How about if that environment's being invaded by us nasty humans, like down in Brazil with the wildfires? Those animals are probably not living as long in the tropical rainforest because we can't stop the stupid fires. It's still burning, or did it finally stop? Does anybody know what I'm talking about? Wasn't like the rainforest on fire for months last year? And I thought still over this summer? Like, I don't know exactly how that happens, but I'm sure we're to blame. Okay, so there's a lot more that goes on with this lifestyle, like lifespans, than there is long jumping. So that's what R squared is about. R squared tells us how helpful are the X's with explaining the Y's. Okay? All right, so the next thing we're going to talk about is a residual. Residuals are all these little sticks. That's a residual. That's a positive residual. Nope. Yes, that's a positive residual because what actually happened is higher than what I predicted. These are all positive residuals up here. And these down here are all negative residuals. So if I took this graph away, and if I lined up all the green residuals and all the red residuals, does anybody know what would happen?
It would be the same.
They would be exactly the same in length because the positives plus the negatives, remember when we did Saturday Night Live? They all added up to 0, right? So this line that's coming through these points is kind of like the fulcrum, the balance point. Just like the mean is for single variable data, this line does it for bivariate data. So that's a residual. And now, to keep the residual formula straight in your head, a residual is calculated by doing the observed y value minus the predicted y value. And the way you remember that it's observed minus predicted is this. Which came first, those dots or the line? The dots came first because the line is calculated shooting up through the dots. So the dots are the observed, they come first, and the line is what we predict. So all of those little residuals can be calculated. And if you add up the positive residuals and the negative residuals shooting through a least squares regression line, it always adds to 0. Now, just so you know, there are many, many types of regression lines. There's called the median regression line, and I can't think of the others right now, but a whole bunch of people, a whole bunch of statisticians have come up with different ways to calculate regression lines, but we only study least squares regression because that's the most accepted. Median line of fit is quite interesting. You divide this graph into thirds, and you find like the median dot of the last third, and the median dot of the first third, and the median dot of the middle, and you line up the last two, and then you move it 1/3 of the way to the, I mean, it's like crazy. It has nothing, it doesn't feel like it has anything to do with algebra. It's all geometry. But it's crazy how close it is to this least squares regression line. And the stronger the correlation is, the closer the median line is to actually equaling the least squares regression line, which kind of makes sense. All right, so one thing we're going to do is actually calculate residuals. And the other thing we want to know is, if I line up all those sticks, how big is a typical residual stick? How big is a typical distance you are from the least squares regression line? And that is called the standard deviation of the residuals, which makes sense with what we've already studied. Because the standard deviation is how far you are typically from your mean, right? Well, now our mean is a line. So we're going to practice some of these. So this is what the residuals tell us, and I think you have this page, and it would be page 33. So on page 33, this is at the top. The residual tells us many important things about our model. We can calculate and interpret residuals. Observed y minus predicted y. So we can tell if the residual is positive, then the dot is up above the line, and if the residual is negative, then the observed dot is below the line. So we either over or under predict. So on this page, you might want to go something like this and say that is a positive residual. So the observed minus the predicted will be positive. And this is where things get confusing. It's a positive residual. It has a positive number as its value, but is it an over or an under prediction? The X represents the actual point. Did we over predict or under predict if it's a positive residual? This is my predicting line. We under predicted. So a positive residual means we under predicted. We did not overachieve, we underachieved. And then something like down here, I guess I can put it in a different color. That right there would be a negative residual. When you subtract the observed minus the predicted, you're going to equal a negative number. And that is actually overachieving or over predicting. Okay. Residual plots detect nonlinear properties. We don't even know what a residual plot is yet, but we will. S is the standard deviation, or the size of a typical residual stick. I always call them residual sticks just because that's what they are, little sticks. And we already learned about R squared telling us how useful the model is. Okay. Any questions yet? This is a lot of information being thrown at you, and then we're going to practice it. All right, so that's kind of what we just talked about. So here is the same thing, just electronically, a picture of that. The residual is the y minus the y hat. Remember yesterday we talked about just letter values being observed values, hat values being predicted, and bar values representing the averages. And this is at the bottom of page 33. To calculate a residual, you have to know 2 points. You have to have your original data point, that is the original data point, and you have to have the least squares regression line. This comes from the least squares regression line. You have to plug the x in to your line and pop out the y hat to get the residual. So now I believe on page 34, we're going to calculate some of these. And I'm going to do the first one with you, and then you can do your other. Okay, so that was what we got for the animals. The predicted years of life equals 6.64 plus 0.03 days. And so we kind of have to have we don't need our short little generic packet right now. We will need it again. I'm kind of paging back and forth right now from this page to page 23. So you kind of have to have 23. And you know what I have that would be kind of helpful for y'all that I can gift to you? I have a whole bunch of them. Where the heck are they? Well, I have a little Post-it note. I was thinking of those tiny little flag Post-it notes. But if you want, I'll give you one of these little Post-it notes so you can page back and forth. I'm giving them all like a tiny little Post-it note to make be like a bookmark. So bookmark page, what was the animals on? 23. Is that what I said?
I said,
Yep. Yeah, we're going to be using 23 here for a while, and then we'll change to a different one. Okay, so for the lion, what was the actual lion's gestation? I think it was 100, if I remember correctly. That's why we picked it the other day. And the lion's supposed to live for 15 years, right? I believe that's what page 23 tells us. Yep, 115. 100,15. Okay. Now I want the observed and the predicted. So I'm going to plug 100 in up above. And we already did this before, but if I do y hat equals 6.64 plus 0.03 times 100, you guys remember I got 9.64 the other day? Yes? That was Monday. It's hump day. Ooh, ooh. Can you believe it? I don't know about you guys, but these days are like, there's hardly any time to turn around. Good news for y'all while we're taking a small break. You know that if you're going to get braces, actually a retainer, they shove that crap in your mouth and make you like bite down on it and it gags you and you're like, how are they fitting that in my mouth? They don't have to do that anymore. They can now stick this little wand, they don't stick it real far in your mouth, they stick this thing in your mouth and it takes all kinds of pictures. Like this little flash goes off, and on the screen, it builds a picture of what the inside of your mouth looks like, all your teeth shape and everything. So you just have to like it's nothing. Because my 93-year-old dad had to get his, poor guy, he like doesn't have many teeth on the top. And the partial that he's had for 20 years now falls out when he talks. So he has to talk and like hold his teeth in, or else just take them out, but then he looks funny because, anyway. So he was really dreading getting a new partial made because he had to get he's like, I gag all the time. I'm not going to be able to do this too well. This is scary for him. And for me, I hate that. But they were taking pictures, but there was a problem. You guys have fillings that I think are not silver colored. Like my fillings way in the back are like silver with some type of metal they put in my teeth when I had to get a tooth filled, but you guys have white fillings now. Well, the silver fillings reflected on this little laser thing camera that they had, so it wasn't being able to make the picture very well. Well, the dentist got some type of paint that's okay for human mouths and painted the tops of his silver fillings blue, and then the camera was able to like do its job. It didn't reflect because it was painted. It was a big day for us. I don't know, it was kind of interesting. Okay, so now we're going to calculate the residual. So the residual is all about the y. So what is y? Is it the 100, the 15, or the 9.64? What's y? It's the observed, correct? So the residual is going to be 15 minus 9.64, which is 4 point what? Well, specifically 4.36. That is a residual. It is a positive residual. So what does that mean? The lion's life was over or under predicted by 4.36? Well, let me think. If it's a positive residual, that means like we go over 100 and up to 15 was the observed dot, right? But the predicted dot was down here at 9 point something. So if I'm going to draw this on the scale, and I kind of like personally to draw it first because I think it's helpful to figure out what we just talked about. So this is x comma y up here. That is the 100 comma 15. The actual thing that I predicted was down here. That's my x comma y hat. And that was at 100 comma 9.64. So my line is coming through like this. And this right here is my residual stick. And that's a positive residual stick. Because I know, because 4.36 is a positive number, and my prediction's underneath, right? So now I can interpret the result. I'm going to say the LSRL predicted a lower lifespan for the lion by 4.36 years. Or you could say, whatever is easier for you to say. The least squares regression line underpredicted the lion's life by 4.36 years. 9.64 is lower than what the actual lion's life was observed to be lived, which was a difference of something like that. That's what I want to know. And this is what I want you to set up for these other ones. So we're going to practice example 2 and example 3 right now. All right? So you guys at home, questions on what we're doing or how we just got this? You guys good? Okay, so what I want you to do, and I can even turn off the class mic here so we won't hear you, but you guys, the 3 of you, can now talk. I'll turn off the mic here, so when you get the beaver done, you can ask each other, and then when you get the raccoon done, you can ask each other, okay? But I think I have to tell you beaver and raccoon first. Is beaver on the other one?
Yeah.
Okay, you have the beaver, but I don't think you have a raccoon, right? Have you ever heard the phrase, somebody raccooned that, like they just ripped into the package and destroyed it? No? You've never heard that? We call it reverted because my sister Roberta does that to packages. So here's what you need for the raccoon. You need the 64 and the 2.5. Because the raccoon isn't on page 23, but the beaver is. All right? So go ahead and do those 2. Quick like a beaver, like a bunny. And I'm going to mute the classroom mic so that the people at home can talk. And you guys here do that. And then share with each other, please. And I'll keep it on there. are already done somewhere, but apparently they are not, so I will get that. So I really want you guys to be doing this individually and then helping each other if you don't get the right thing. Check with somebody after you calculate the beaver. See if they got the same residual as you before you go drawing the curve and everything. All right, you guys can get up and move. And I think you guys at home can still hear me, right? Just give me a thumbs up. So I want you guys, we can't hear you right now, so you three need to talk to each other once you get the calculation for the beaver. Make sure you all have the same number before you go drawing it. I will show you, the raccoon. The things you need for the raccoon were 64 and 2.5. Did you guys get that as your residual? Whoops, not that. Did you get this as your residual? Negative 5.3. So then draw it and interpret it. And then please do the raccoon. Beavers are so cute. Are beavers and woodchucks the same thing?
Yes. No. Groundhog.
How much wood can a woodchuck chuck if a woodchuck could chuck wood? Lots of wood. Although if you have a beaver in your yard, you don't like him because he's chopping down your trees. All right, I'm going to reveal the rest of my beaver. So we had an over prediction here. Maybe it's because trees fall on the poor beavers. Yes.
Do you have to put the negative because it's still
don't have to put the negative. Yeah, because that would be, I understand what you're saying. All right, try the raccoon and check on that one too. You should see Miss Hearns' socks today. You would like them. Lucky duck?
Chick magnet.
Chick magnet. Oh, lucky duck, chick magnet. Hers are Halloweeny.
Yeah, I don't have very many Halloween ones. I have a lot of Christmas and other stuff.
I gotta look up who that boy was that had all those socks. So is this something you get a lot for presents?
Yeah.
Yeah. I make it easy for everybody else. I don't have to be very creative to give them stuff.
Yeah, I got a sock shirt.
All you gotta do is give me a shirt and like
Sure.
socks. That'll be
Last year at Christmas, he like doubled Sam's wardrobe.
Yeah.
He wears
They
like
make
3
fun
shirts.
because I wear
He
like
wears 3 shirts.
I wear like 10 shirts, but I have a bigger drawer, but I only wear the 10 most comfortable ones. They just make fun of me. It's like 5 million shirts.
I can understand just wearing comfortable.
Can we take a break? Or do we not have time for a break?
Pardon?
Can we take a break or do we not have time for a break?
We don't have a whole lot of time. You can stand up and take a small break right now if you have this done.
Yeah. You don't have like a whole like organization. Not to just make fun of you. Well, it's less time to do school. We'll walk. Just go all the way to like where you guys catch them. So you go, like I go to my locker all the way, you have to settle over seat. Just do that's like 5 months. So,
All right, we're going to start up again in a few minutes. And it's not going to be me talking. I'm trying to remember who the heck I had that was the sock guy. I can't find him. I will. Michael Koniar. I believe that's who it was. Michael Koniar. Pretty sure that's who it was. Let me look at his face. Okay. What we're going to do next is I'm going to give you a few minutes to work with your groups. And whatever you don't get done, yep, it was him. So I wonder if he still wears all his socks. Okay, you guys can join us again. I'll turn your volume back on so I can hear you. Okay. You guys okay there at home? Did you get the beaver done correctly? Okay, and here is the raccoon answer, maybe? There we go. Did you get another negative for the raccoon? All right, so what we want to do right now is we're going to practice some of these things. We're not going to do the backpack right now. On your packet on page 36 and 37, there are some exercises to do. You don't need your book because we wrote them down. And we're going to give you until, until 9 o'clock. So you three know which breakout room to go to. You guys can go to your breakout rooms. Go ahead and form your groups. I think, was there a group that worked out in the hall yesterday? A couple groups maybe? You can go there again, but just make sure you're really 6 feet apart. And whether or not you get finished, you're coming back in here at 9. So there's the front and the back to do. Page 36 and 37. And we're not finished, but because there's one more thing I have to teach you, new thing. All right, so if I win, 9 o'clock, we're back together. Yeah, that's fine. Do Sam or Bella have a way to get in touch with the
Yes.
Yeah, we don't really like.
Jenna and Alice?
Need to talk till like we finish. I don't know.
Yeah. Well, just make sure that Zach knows you're there.
And then like you can, even if one person's on, you can still hear the other person. Yeah. That's why it's so difficult to harmonize with you.
Oh, because then you can't hear each other.
Yeah. So,
You can probably just not even wear put your Chromebook right here so he can see both of you, and then you can talk. It's 1 and 2, I think, right? Are you guys?
hello, Jeff. Maria's right there. And I'm there.
I can't see Zach. Where are you, Zach? I see Maria.
I'm using my desktop so I can use a headset instead of my Chromebook so I don't have a camera. I can switch if you'd rather use
Nope.
the camera.
You're good. You're fine. Thank you.
Which one? That one? The second is the negative 0.00 factor. Like which one? Is it like the add or? Oh, I have my packet right here. I also.
As x increases by 1. Slope is the as.
There's so many sentences in this chapter.
I know. That's why we made the little clip notes for you. So you don't have to go rooting through the big packet to try to find it.
y-intercept's still predicted, right?
Yes, everything's predicted off of that equation.
What's the difference? As the weeks, so when we execute, I'm saying as the weeks increase by 1 week, the pH levels are predicted, or are predicted. Decrease? Yeah.
Allison?
All right, Jenna and Alex, how are you guys doing? Okay. Oh, Jenna and Alex, how are you guys doing? Okay. Something's wrong. Let me see. Okay, go ahead and talk again.
0.00531.
Okay, you don't have any questions for me at this
I
time?
don't know, is that acidity? or-
Okay, make sure you're checking with Sam and Bella when you get the answers to your questions, all right?
Acid. I'm just gonna say acidity.
Hey, Zach, how are you doing with this?
Oh, I'll turn that up.
Oh, that's okay. How are you doing with the material, Zach, so far? Oh, I have you. Okay, go ahead and say that again. Excellent. Okay, go ahead. You can turn that back up. I just wanted to make sure I could still know how to do that. All right, now I'll go out and be the social distance police. Yep. Do you guys have any questions? Don't get too bogged down in the 45. I think if you're having trouble, just skip it. It's not an actual thing.
Acidity and the, it's not, but I also go in. I'm just gonna not equal.
Yeah.
pH levels are predicted to equal, I think it's just the pH levels, like,
Yeah, I don't,
are predicted to equal 5.43.
yeah.
Oh, 150 plugged into. And then that's it. Yeah, how do you 150 in the, oh, okay. Understood.
Don't get bogged down on 41. You can skip right to 45.
And that's 6.225. I just pump it off.
You can skip right to 45.
That's, okay, that's what I got too.
Because it's just 5.43 minus 0.0053 times 150.
Yeah. So when it's worth the point.
And of course, you have to like just square it at the beginning of the first block for everybody to see, and then you can take it out. Okay.
Wait, but what, when I do 150 times that, I get negative 0.7 that. When you do like the negative 0.0053 times 150. Oh, I just did that as positive times. Like I just did positive 0.0053 times 150.
You're off the hook, Sam. You don't have to be the pumpkin.
Yeah, because then,
Oh, good.
then you subtract it from that.
Who's the other?
Well, yeah, but
Liz is gonna be the
negative,
pumpkin.
and
She's
then
gonna
you
get some
subtract
extra
it, and then
credit.
it's on.
Sam don't need no extra credit.
Yeah.
Just 5.43 minus 0.0053 and then parentheses 150. Because that's
We have to do it in that? Can you switch the order
For what?
for C? Like when you multiply, or like the equation, like plugging in 150.
You have to put in 150 times the negative and then do 5.43 minus 5.
Okay, so
Or you can just plug into your calculator 5.43 minus 0.0053 times 150. Enter. Which basically means there ain't gonna be any more earth here because the acid's gonna be so bad, everything's deteriorated away.
Yeah. 1,000 months is quite a bit of time.
Oh, yeah, well, yes. If the acidity kept going like that.
we have to do 41 then.
Well, you can do 41, but what do you have to do first? Divide that by 52 to put it into weeks? No. You have to divide it by 12 to put it into a year, and then divide it by 52 to put it into weeks, right? Or multiply by 52. Yeah.
So, what do you do?
Okay, you guys have like 4 more
I have
minutes.
one, I mean, I can figure out around
Okay. What you get for ABs?
about
Oh, wait, ABs, what
4,000.
you get for C?
1.635.
Okay, and then 41 is no.
252.
Yeah.
125.
Yeah.
4,000.
I think probably not A and B.
Yeah. Okay. Now, what do you do? He's just asking what this is supported. Yeah. So we could still plug that in.
Yeah, you just have to explain how you get into weeks.
And 45. I think just what we did.
daughter's East Western Reserve address. Is it in your phone?
Terry. So the you have the first coordinate, which is
I might have her, just wait a
5.08,
second. I'll just ask
and
her
the second
directly.
one is going to
No, wait, just wait, let me see something.
whatever we get from the equation. Yeah. The equation is 5.43 minus 0.005. And then 50. I also got 5.
Mine says ice my husband in case of emergency.
And then now we just do, which one is it 5.08?
Well, if she gives it to you, text it to me, because I want to send her another one.
We're not like drawing on the graph. I don't think so.
So we just say seconds.
Yeah, wait, so it's, well, first, yeah, 5.08 minus 5.165.
Oh, you said
Maybe
that.
0.085. So then percentage is,
We all follow that, but everybody else.
yeah,
She looked just like Buffy.
so is it 8.5% of the variation?
But you didn't say Buffy, so you call it Buffy and it's stuck on. You can just,
Shows up on.
yeah, thank you. And if it doesn't, I'll try to remind, text you, remind. But she's down there, right? and loving every minute. That's the way it should be. Okie dokie, guys, come on back in.
Isn't that in the same thing?
Over negative.
Okay, tell them to get back on the regular meet.
I just skipped it. You're at section.
I know you didn't get, to finish everything, but. Alrighty, so we're gonna go over some of these, and we have one more thing to do before you guys can leave. Can you guys hear me? Do I have everything on okay?
Yeah, I can hear you.
Okay, excellent. So you guys can see my presentation also, or not?
I'm seeing the Google Meet right now.
Okay, then I need to present again. Something happened. It says I am presenting. Oh, what if I do that? Can you see that now?
Yeah.
Okay, I must have it on frozen. Okay, so for this first one, we have that equation, and the slope would be as the weeks increase by 1, the pH is predicted to decrease by 0.0053 units. That means it's becoming more acidic out there, which is not necessarily a good thing for forests. The intercept is 0,5.43. When the study began, or before the study started, the predicted pH level was 5.43. And then for part C, if you put in 150, we get down to 4.635 units. And if you got to, here's the pH scale for you. So we're really getting towards acidic there. If you got to number 41, which I encourage some people to switch, because 1,000 months to change it into weeks, I would recommend first dividing by 12, and then multiplying by 52, so that's 4,333.33 weeks, and it's not appropriate because it's extrapolation, and you would have a negative 17.536. There would be so much acid that the world would basically not be here anymore because it would have eaten everything. So that's extrapolation. And all of this will be out there online if you're not catching it. For 45, it said find and interpret the residual for this week. If the observed data point was 50,5.08, if you put 5.08 weeks in, no, I'm sorry, if you put 50 weeks in, you end up with 5.165. And so the residual is negative, and what does that mean? That actually means something good. That means our prediction was too high, which means that the acid rain wasn't as bad as we thought. I believe that's what, yes. And then the last one, and it's okay if you didn't get to these. We actually already did problem 40. So I was just, you did that for homework the other night. We interpreted the slope and the intercept. And so then for 46, if the observed point at 46.4 degrees Fahrenheit is 490, if you go back to the equation from number 40 and plug in 46.4, you would get 5.03, which is more gas than expected. So our prediction is too low, and that basically means the actual gas consumption, it's lower than predicted. So we predicted more gas than they used. And if it's anything like our house, we turn the gas down during the day when we leave, except for now that my father's living with us, we don't save as much money on heat during the day because there's actually somebody home and he is a freeze baby. Like when it's 70, 80 degrees outside, he takes a walk in a coat. But I think that's typical of a lot of older people. Okay, what I want to do now is go back to your Cliff Notes packet, if you would. We're going to talk about the residuals, and I know that was really fast. We're going to talk about the size of the residuals. So the standard deviation of the residuals is the formula you see. It's also written on page 9. Page 9 is going to look like this. So that's our formula for the standard deviation of the residuals. And we need to highlight this sentence because it's one more sentence. Are we done with all of our sentences? Almost, but not quite. All right, let me try that again. This is very, very similar to what you've had in the past. And I will show you what we're actually doing to make a residual plot, and tomorrow we'll actually do it in our calculators. This first graph is a least squares regression plot, and if you take that plot and if you rotate it so that your regression line is horizontal and then kind of zoom in a little bit, that's how you get a residual plot. And so the standard deviation is taking all of these sticks and all of the top sticks, and we want to know what's the typical size of one of those sticks. That's what S represents. So let's go to the backpack page. So we have page 9 out in the small packet, and the backpack page, we're on page 13, and we're going to finish page 13 today. That's the residuals. Standard deviation of the residuals is 2.27. We already did R squared, so now we're going to do S. This we already have done. S is 2.27, and remember that X equals our body weight, and Y equals our pack weight. So if I do this sentence, I would say 2.27 pounds, that's the unit, is the standard deviation of the residuals. So what does that mean is what's coming next. Basically what that means is, oh, sorry, I'm back here. What that means is, I'm trying to hurry. Okay. What that means is the following. This is the typical amount and observed. It's all about the Y's. R squared and S are all about the Y values. And observed pack weight differs or varies, whatever you want. I think we used varies before, but you can use differs. Whichever term you want, I'm okay with that. That you get to have a choice on. From its predicted pack weight. And where does the predictions live? Where do all the predictions live? Where do all the y-hats live? On the least squares regression line. And you can abbreviate least squares regression line. Yes. Sort of, yes. And I'll explain that more, but you don't have to worry about that right now. Okay, this is your homework. There are a lot of A skips, and whenever it says interpret R squared and interpret S, you need to use our sentences. There's a whole lot of them. And I will put a homework hints out there, and on the hints I'll say, okay, for 47, You need to have the R squared sentence and the S sentence and the slope sentence or something like that. And I'll send that to you in a remind text also. So it's going to take a little bit longer, but you've had really short assignments the last couple nights. You know how I got A skips? Oh, you guys at home? Do you have any questions for me? We'll work on this a lot tomorrow, but we got through everything we needed to talk about. We didn't practice S very much, but. All right, have a good day. You guys have a good day. Good luck, guys. Any soccer players?
I did.
What position are you?
I don't know. Bribery.
Left defender? So are you like a sweeper or are you above them?
Slightly above.
So you're the row right before the, what are the two? There's a sweeper and a, oh, okay.
What do you play?
Yes. Is it gonna be televised, like live stream? I can't imagine that they wouldn't. I know, but I can't imagine that they would. Well, good luck. I think it'll be kind of wet. Come on in. All right, I have to pause.